For there are three types of load. One is the resistive load, another is the inductive load, and another is the capacitive load, right? So in the resistive load, current and voltage are in same phase, right? In the case of inductive load, current lags voltage by an angle phi. In case of capacitive load, current leads voltage by an angle phi. I told you not to remember C will word, right? C is for capacitor. C is for capacitor. I, here you can see that C is for capacitor. I is in front with voltage. So I is leading the voltage in case of capacitor. Okay, here L stands for inductor, which is in front, voltage or current? Voltage. So voltage is leading in case of inductor. Here write down like I lags voltage. So it means V is leading current. Okay. If voltage and current are in same phase, means voltage is on the x-axis, then in that case current is also on the x-axis. Okay. If current is lagging the voltage, means voltage is always on the x-axis, current is lagging means current is on the downward. In case of capacitor, current leads voltage, voltage is on the x-axis means current is leading, right? Current is leading. So here in this case phi angle is 0. So in case of resistive load, cos phi is 0 means cos 0 is 1, and it means there is a unity power factor. Okay, it means there is a unity power factor, and in this case, inductive case, there is a lagging power factor because in case it is lagging, and here it is leading power factor. So whenever they'll ask you where the power factor, you have to mention in bracket that whether it is a leading, lagging, or unity. Okay, clear this thing? Next is the case for the poly resonance. Yeah, resonance. We are having one condition for the resonance. What is the condition for the resonance? Can you tell me? That is XL must be equal to XC. XL is equal to 2 pi FRL, because in the case of resonance, resonant frequency is different. XC is equal to 1 by 2 pi FRC. So FR formula would be equal to 1 by 2 pi root LC. Correct? So if XL equal to XC, then Z is equal to root of R square plus XL minus XC whole square. In the normal condition, if XL is equal to XC, then Z is equal to R, right? In this case, impedance is minimum or maximum? If Z is equal to R, then in this case, impedance is minimum or maximum? Tell me. It is decreasing or increasing? Impedance is earlier it was, earlier the formula is like this. Now the formula is this. So now the impedance is decreasing or increasing? Impedance is decreasing now. Earlier the value is this one, like you are having R square plus XL minus XC square. Now the value is Z is equal to R only. So your value is decreasing or increasing? Decreasing. So Z, in this case, Z is minimum. If Z is minimum, then current should be minimum or maximum? I is inversely proportional to R. It should be maximum. Okay, clear? So these are the condition for the resonance. If they'll say that impedance is minimum, we have to understood that this is the condition of resonance. If they'll say current is maximum, then in that case we'll understand that this is the condition of resonance. Okay, they'll never directly say you that we are using the resonance condition. And if there is a voltage drop, like resonance condition is good or bad according to you? You tell me, resonance condition is good or bad? Resonance condition is good or bad? In this case, there is a power factor is unity or not? If Z is equal to R, then what is the value of power factor in case of resonance? And unity power factor is the ideal power factor, right? Unity power factor is the ideal power factor. So, but there are some disadvantages and some there are advantages. What are the advantages? That in this case power factor is unity, that's good for us, okay. But in this case current is maximum. If current is maximum, then the I square R losses will be losses will increase or decrease? Increase. So if the losses are increased, then it's not good for us, right? And if current is maximum, then the voltage drop across that will be also maximum, right? So some of the conditions are not good for us. So in overall, if we'll consider that resonance is not good for us. Okay. Now we'll start. Which one? This one? See, what is the formula for the voltage? There is a resistance. Okay. Suppose of 5 ohm and there is a current flowing. So the voltage drop across. If current earlier it was 2 ampere current, and now the current increases from 2 ampere to 4 ampere. Okay. So in which case voltage consumed by the resistor is more, first one or second one? Hmm? Second one. So in which case voltage drop is more? Here this is the condition of maybe resonance, because here its current is increasing, but here the current value is not so much, so the here voltage drop is less. That's why I said in the case of resonance voltage drop is more. Okay. Darren. Darren. Okay, okay. Next are for polyphase. Have you done any question based on resonance, Darren?